Let's solve this integral.
The indefinite integral of x squared over the square root of 9 minus x squared dx will be solved using trig substitution. The trigonometric substitution rule we'll use here is when we're dealing with a squared minus x squared, we'll set our x value equal to a sine theta. Because our a squared value is 9, we'll set our x equal to 3 sine theta, and our dx is the derivative of x, which is 3 cosine theta, d theta. Now that we've assigned our x and our dx values, wherever we see an x or a dx in our original integral, we'll replace with our new values in terms of theta. This will leave us with 9 sine squared theta, 3 cosine theta d theta over the square root of 9 minus 9 sine squared theta. The key to trigonometric substitution is being able to recognize and replace using trigonometric identities and moving things around until you're able to integrate. In this case, we can recognize that 1 minus sine squared theta is equivalent to cosine squared theta. To get to that point, we need to factor out a 9. This will simplify down to 9 sine squared theta cosine theta d theta over cosine theta. Those two cosine thetas, one in the numerator, one in the denominator, will cancel, and we'll be left with 9 times the integral of sine squared theta d theta, which we can solve using the reduction formula for sine to the n power theta. This will leave us with our answer in terms of theta of negative 9 over 2 sine theta cosine theta plus 9 over 2 theta plus c. This is our answer in terms of theta, but we need to replace it in terms of x because x is the variable that was given in our original integral. We'll do this by using a right triangle, SOHCAHTOA, and the Pythagorean theorem. Using our x value from the beginning of our solution, we know that x equals 3 sine theta, so sine theta equals x over 3. Sine is equivalent to opposite over hypotenuse, so we'll put our x on our side opposite our theta and our 3 as our hypotenuse. Using the Pythagorean theorem, this leaves our adjacent side equal to the square root of 9 minus x squared. Using those values in SOHCAHTOA, we'll go ahead and replace our answer in terms of theta with our answer in terms of x. To solve for theta by itself, we'll use what we already know. If x over 3 equals sine theta, then the inverse sine of x over 3 is equivalent to theta. Once simplified, our final answer is 9 over 2 inverse sine of x over 3 minus x times the square root of 9 minus x squared over 2 plus c.